welcome to the Node.js meetup. Also, the first Node.js meetup of 2019. It's been a couple of months since we had a meetup because we didn't end up having that the holiday party like we wanted to. But I hope that everybody had a great December. Just a really quick ask, how many of you is this the first time at the Node.js meetup?
Yay!
Awesome!
You.
Michael, you've been here since the beginning. Well, welcome everybody. I'm glad you can come. My name is Brooks Patton. I'm the organizer of this. We also have Michael Herman in the back, a co-organizer, and Austin somewhere back there. He's helping us out too. All right, so there's a few people that I would like to thank before we begin. First of all, we have a great, awesome array of food here, including pizza and salad, which I've now decided to make as standard for the meetup. We can thank Google for that. They're sponsoring us and providing the food. We also have a sponsor for the wonderful drinks and the space here, Code Talent, and in fact, we have a representative from Code Talent here tonight.
Hi, I'm Maury. I'm one of the newest recruiters at Code. I have cards up there and back by the pizza. For Node, we have senior level roles open at Guild. And then we also have a ton of clients that are open to code agnostic, ramping up, stuff like that for senior engineers. So if you're looking, let's connect. Send me your resume. Even if you're just passively looking, let me know.
Yeah! Does anybody else have any announcements or things they'd like to say to the community?
Thank you.
All right. Well, you're welcome. I'm super happy to do these. I want to bring the community together, and hopefully we can put Denver on the map for the world, on a good place to come find developers and talk. All right, the other thing is we are recording this. We have this entire setup and live streaming it. So when we come time to questions, we may have questions from the audience. And if you're watching on the live stream right now, please ask questions in the chat and we'll forward those on. We're also going to put the VOD of this on YouTube, so if you want to go back and watch it later, you can find it there. I'll put the link in the meetup page. So, without any further ado, our speaker tonight is Kyle Coberly. I worked with him for a few years when we ran a school together. Now Kyle is a, what's your official title?
Where? The technical director of technical lead in health scholars and executive director of development.
Yeah, so he puts on a conference every year, which if you haven't been to, awesome conference. But you didn't come here to listen to me talk, so I am going to give you over to the capable hands of Kyle.
It's going to be a lean night.
All right. So let's talk a little bit about programming without ifs. My name is Kyle Coberly, and a little bit more about myself. 3 things. I'm an educator, so who here knows what Galvanize is? Just about everybody here, right? Well, me and Brooks and Kim and a couple of us ran that school for about 3 years. I'm also a business dork. I have a master's in engineering and engineering management, and I run the Develop Denver conference. I took that over this year from Drew, and we start planning next year on Wednesday. And we have a lot of big plans for this year, and we think that's going to be a pretty cool thing for the community. And I'm also, believe it or not, a software developer. I am, as we just talked about, technical lead at a company called Health Scholars. It's VR clinical education for doctors and nurses. And I'm a pretty active Node user. I ran the Ember meetup for a few years, and now I spend most of my days in Vue land. So, by the end of this talk, I hope you'll be able to define cyclomatic complexity. I'm going to give you a cool vocab word sound, cool to work with tomorrow. I want you to be able to recall 3 ways to avoid using ifs, and I want you to be able to recall 3 ways that if you do have to make an if, you can use it in a slightly more sane way. So, cyclomatic complexity. This is one of these things, if all you take out of the talk is at least remembering this word enough to look it up and get a definition, this is how you sound smart in an internet argument. You're like, the cyclomatic complexity is out of control. And everyone will go, yes, yes, indeed, because cyclomatic complexity sucks. Cyclomatic complexity is the number of independent paths that you can take through code. So let me give you an example. This is what we call an execution graph. If you think of a function, a class, a module, anything where the code kind of runs top to bottom, then you might say, all right, so we start somewhere, we do something, and then we go down, and we do something else. There's 2 things I want to call your attention to on this graph. Well, I've actually never used the laser pointer function. I know Brooks just focused the camera on me. Sorry, dude. So here, we might go, all right, we do this thing, and then we come back up here, and then we do this, and we do it again. That would be a yes. In regular programmer language, we call that a loop. All right, loops do not add to cyclomatic complexity, believe it or not, because the code always ends up going through that pathway. So where we really get into cyclomatic complexity is this next one, where once we hit this point, we can go to here, or we can go to here. And they both end up coming to the same place. That is our conditional. And that's where we get cyclomatic complexity from. So we do this in code. It might look something like this. So I'm writing a talk, and the first thing that I do is I do some operation. I get books on cyclomatic complexity, that's my learning materials. And then I iterate through all of those and build some array with a for loop with each of the learning materials. So that's our loop. I haven't added cyclomatic complexity yet. It's once we get to here, we go, all right, do I know enough? Well, enough is infinity, and I know less than enough, so I return this. Otherwise, if I did know infinity, then I would give you all my good wisdom. Sorry, even though it's a condition we'll never get to, still counts towards the complexity of the function. So, cyclomatic complexity of this is 2. We essentially have 2 different pathways that we can go through. The one that just kind of goes straight down here, or the one that goes through that. All right, so did anybody follow that one of the many arguments in code opinions today on Never Devs? Specifically the one about code comments? No one? Oh my goodness.
How many of you know about Denver Devs, the Slack team?
Okay, there should be more of those hands, but I highly recommend a channel called Topic Code Opinions, where it's topic code opinions and also topic architecture and topic cyclomatic complexity. A lot of the stuff that doesn't fit into a normal channel, but is fundamentally something that you may or may not be opinionated about, happens there. You learn a lot being in that channel. You also see some really cool arguments. For example, today we were arguing about whether or not comments are worthwhile. I'm a pretty anti-comment person in general, but in a lot of the examples that people were giving, it was like, well, with this mega nested if thing and with the loops inside it and all this sort of shit, I was like, well, don't write your code that way, and maybe you don't got to write the ifs. So this is some shit that Alex Dreeth posted. I have no clue what it does. And it has these nested ifs. So if the first batch, if has children, then we call these things. So any guesses what the cyclomatic complexity of this is?
4. 3.
Right.
3.
So let's talk about the different pathways that we could take through this. The first is that nothing happens. So that would be, this first condition doesn't match, and so we go right through. That is one possible code pathway through this. Next thing that could happen is this first thing is true, but this second one isn't. So still, nothing happens, but that is another possible branch to the code, through the code. And then our third option is this one's true and this one's true, and so that these two things run. Our cyclomatic complexity on that is 3, which is an awful lot for something that kind of does one thing. To give you an example of how we might start un-ifing that, this is the one that we had before in the last slide. And so if we just combine these two conditionals, now we only have 1. Guesses in the cyclomatic complexity of that? 2. So already we're making we're lowering our cyclomatic complexity. So cyclomatic complexity is caused by ifs. Ifs can take an awful lot of different shapes, but it's fundamentally all these kinds of things. If, else, else if, all of those add to cyclomatic complexity. Some ones that might not be quite as obvious, case statements and a switch, each one of those is another code pathway. Catch, that one's kind of sneaky, because you may or may not end up running through a catch block. Either of the Boolean and, Boolean or, both of those, and that one's really sneaky because it's so tight, but you are technically doing something that may or may not run. Or a ternary. All of those are different kinds of conditionals. So that's what cyclomatic complexity is. Who gives a shit? It sounds like a big, another CS-y kind of thing, like lowering the big O of your code or something. But much like big O, there's reasons that we care about this. The biggest one is that when you have high cyclomatic complexity code, that's more code pathways that you have to test. If you want thoroughly tested code, every possible branch of execution, you would nominally want to write a test for that. Especially if those may behave differently with different values. Now that's a multiplier on the number of tests that you need to write. And it's not always obvious just how many of those there are. So having confidence you actually have the coverage, that's pretty rough. It's more points of failure. All those different branches. This is where I really see this happen, is in enterprise code, you may have one of these like guard clauses or something like that that doesn't run very often. And so once a month you get an error. All right, well what caused that? I don't know, the code's been working fine for a really long time. It might be hiding in one of those branches that doesn't get used very often. A lot harder to extend. As we take code, we want to make sure that that keeps working, and we don't want to fuck with the logic of it or anything, but we want to add new functionality to it. When you're using a lot of conditional logic, you maybe add another else if block. Okay, well, does it matter where the else if goes? Can we just add it to the front? Can we add it to the back? Because sometimes those things change state in the function. Uh-oh. Now we don't have confidence that we can do that. Also, it gets super awkward to just say, to add the else ifs and the braces and all that kind of shit. And then lastly, it's a lot harder to read. Being able to look at a function and tell what it's doing becomes a lot more difficult as soon as you start dealing with conditional logic. So let's do an example. This is something I found online. This isn't JavaScript code, sorry. Ran out of time. But this is relatively high complexity code. And I think we can illustrate these points we just talked about a little bit. So as far as things you test, I'll just tell you the cyclomatic complexity of this is 5. Would you know that you need to write at least 5 tests? Or at least whatever other conditions you have times 5? Probably not. It's not super obvious looking at it how thoroughly you need to test this. As far as errors, places that buggy code could hide. Holy shit, does that look like a lot of little hidey holes where a very fiddly error that you might not see that often might be hiding? Hard to extend? You're goddamn right, man. Let's check this out. We have this. That's not a conditional. That's a statement. That's a statement. That's a statement. Do those mutate the state of the application in a way that matters to me? If I'm adding another conditional check to this, am I confident that I can just put it wherever? Probably not. And then lastly, readability. So as an example, what I mean by like how hard this is to read, that is the only thing that is guaranteed to run in the application. That's an awful lot of function bulk when that's the only thing that I'm sure is going to happen. So as another example of something that could happen in an execution, it's just that, nothing else happens. So I call that function, most of it doesn't run. Here's another potential thing that could happen. That green doesn't show up super good. But we might have something where this statement gets called, this test runs, doesn't pass, so we move on to this statement, and then we see this test, which doesn't pass, so it goes to an else block, and then calls this, and then calls that statement. So just looking at it, whatever the state of the application is, now I have this like crisscross spots that do or don't run. Ouch! That's really rough to kind of wrap your head around. So that's all. Cyclomatic Complexity, the Wikipedia article is like a pretty long read. And it's a very dry academic subject. That's all we're going to talk about for it tonight. What I'd like you to do right now, turn and talk to a neighbor and see if you guys can come to a shared understanding of what is cyclomatic complexity. Go.
Pathways over tiles. But if your code is good, I think the tricky bit of this.
10 seconds.
If you write it, very
All right, wrap up your conversation. And back with me. Excellent. Now you get a volunteer. Give me a solid definition of cyclomatic complexity. Filthy Phil.
Number of pathways through your code.
Oh, I love it. Round of applause for Filthy Phil. Okay, that's our first learning objective. Next thing we're going to talk about is what can we do about it? All right, so conditional logic kind of screws up our code. So there's 3 if-free strategies that I'm going to talk to you about tonight. The first one is using functional chains. Second one is dictionary lookup. And the third one is dynamic dispatch. Also, that's another one like cyclomatic complexity. You drop that one at the office tomorrow. I'm like, oh man, we're not paying this cat enough. So these aren't things that will apply to every single situation. But if you go, man, I'm using an if here, that's pretty smelly. What tools do I have at my disposal? You think through these 3 things, I'll bet you find a solution. So let's look at the first one. So functional chain, the problem we're trying to solve here is we're trying to do an announcement that announces the day of the week. So we have the days of the week in an array right here. We have this function that takes in a message and then poops it out with an exclamation point. Pretty simple, right? So the way that you probably learned to do this when you were starting programming is you iterate the for loop through the length of the weeks, and then you maybe test to see if the day of the week is a Saturday, and if it's not that, you go, all right, well, is it a Sunday? Okay, cool. So it's neither of those things. That means that we can announce the day of the week. Like a really common way, and in that argument we're having on Denver Days, there's a lot of this kind of reasoning. So a better way to do this is maybe you say, all right, I've got Saturday and Sunday, those are specifically weekend days. You take a difference of those, and then you do an applicative on whatever the result is. You can do the for loop too, but this is kind of the idea, is we want to think about, all right, so if I'm not using everything, what do I need to cut out, and then work with that. And if you're doing things that don't mutate the original arrays, then we can chop up and chop up and chop up. We can do this a bunch of different times. And if we're doing those sequentially, we don't mess with our big O either. It might be O of 3n, but it's still O of n. And with a lot of stuff, the size of n isn't big enough that whether it's 3 or 6 or 20, probably doesn't even matter that much. So the way that I would actually do it is, you might think that the one with the temp variables reads a little bit easier. You might be right. I tend to like doing it more this way, where you take in this original thing, and then we do that difference kind of in place, and then pass it to in each function. Your mileage may vary, but this is the idea of, we could do that with no explicit loops, no variables, no kind of imperative logic, and now we have a cyclomatic complexity of 1, because it has to go through that entire chain, whether or not it's a weekend day. Pretty cool. So, all right, that's our first strategy. We use this one for data transformations mostly. Second one is dictionary lookup. If you got switch statements in your code, this one should probably be your go-to. This is a great way to just get rid of a switch statement. And the general idea here is that we're going to take all of this imperative logic, where it runs from top to bottom, and we're going to extract data out of that. And we're going to have the thing that operates on the data be separate from the data. So the big magic trick here is that we take all of those different cases in our switch statement, and we make those into a little dictionary. We say, all right, well, if it's Monday, then this is the value I want to have. It's Tuesday, Wednesday, whatever. These are the values that I want to have. And now my actual programming, the thing that's operating on this data, just deals with what it is. Think about for a sec how many fewer places there are for a bug to hide. When I was typing out this example, you know how many times I forgot to put in the fucking break? There's just a lot of different places for this to get weird. Also, I can write a test for the behavior of announced day that's separate from any particular data that happens to be operating on it. So now I have one test versus 7 for the original switch one. And we talked about extensibility being an example here. Let's say it's not days of the week, but it's something with a lot more cases to it. You can write you can add a key to an object. You can do that dynamically. You can do all kinds of great stuff to keep your data separate from the thing that's acting on the data. All right, so you got switch statements. That's probably what we're going to call dictionary lookup. But there's one exception to that, where it's not just setting values or returning something simple. It's got maybe some calculation to it. And that's going to be our third one, dynamic dispatch. So the example code here is a function called doubler. And doubler behaves differently based on whatever type of data that you pass to it. So if you pass it a number, it doubles the number. If you pass it a string, what it does is it just repeats every letter in the string. So double would be DD, OO, UU, that kind of thing. So this is like fundamentally different behavior, and this is like another thing that people really reach for switches pretty readily on. The way that you would do this with dynamic dispatch is really similar. You're going to make an operations object with each of the different behaviors you want. So the difference in the last one is these aren't simple values, these are actually functions. And so we take the logic for both of these, and just like before, now we have just the logic. This takes an input, we look up what function that we should have, and then we pass that input into it. This is like polymorphism at its core. This is anytime in object-oriented programming when you call a method that is kind of determined at runtime, you just shout something up the chain. That's this exact same thing. And a more functional approach, a little bit more common in Node, we would expect to see probably something more like this. Another thing you can do, a pattern I've seen on this, is you may or may not know that functions are also objects, and you can set properties on them. So you can even put this lookup on the function itself for bonus points. All right, so that's the core idea behind dynamic dispatch. All right, so to review, these are our 3 strategies for getting rid of ifs. Functional chain, data transformation. Data looks like this, needs to look like this. If you're doing a bunch of ifs and stuff in there, figure out, use Lodash, Ramdas, like the ES5 applicatives will even get you a pretty decent amount of the way. But see how you can chop up the data that you have into something where it will work on every single element on it. Dictionary lookup. So if we're just looking up data that could have a lot of different options to it, dictionary lookup's the one we want to do. And then dynamic dispatch, if we have variable behavior in something, we want to look up that behavior in kind of a similar way. So I'm not going to have you turn and talk on this one, but I would like you to think for 10 seconds what the 3 ways to get rid of ifs are. Think to yourself. I'm going to give you 10 seconds.
Can you go back to the hospital?
Nope. This is how you learn something. You got to make your brain hurt. All right, somebody who isn't Mike Herman or Filthy Phil, would you like to volunteer? What are the 3 ways that we can get rid of ifs? 3 of the ways. There's more. No volunteers? Come on.
Kim.
Functional chains,
Functional chain is 1.
dictionary lookup,
Dictionary lookup's the 2nd one.
dynamic dispatch.
Hey, I have a round of applause for Kim. All right, everybody else, I'm going to post a slide deck. You got some review to do. All right, so this last thing we're going to talk about is sane if strategies. Getting rid of ifs doesn't always make your code better. Sometimes the trade-off in cyclomatic complexity is worth it if it's just a little bit more straightforward. For example, 2 facts. Before this talk, I looked this up. In my day job, I oversee a roughly 20,000 line code base. I looked it up earlier. There are 24 if statements in 20,000 lines, which not bloody bad. However, not all of those 24 if statements are like accidents or something. Sometimes it was just a lot more clear to do it that way. But there's good and bad ways to do this. I'll give you one more example. And that like some shit that Dreeth posted function, I was trying to get that down to a cyclomatic complexity of 1, but it was dealing with a lot of thises and like pulling stuff out of closure and reference. And without knowing more about the code, it was I got there and I was like, this is not a good example to show because like nobody should do this. This is like too gnarly. So sometimes we want to use ifs. So our 3 strategies. First one, flattening nested ifs, wrapping blocks in functions, and returning a ternary. These are 3 strategies that will help your if game get a little bit better. So the first one, if we look at the some shit Dreeth posted from earlier, we have, all right, well, first batch is this, and this one has children. There's no other conditions, though. We can make a little matrix of all the different options. And even if, like, we look at that gnarly Java one from earlier, there are a finite number of matching conditions. So what we can do is use, kind of push that into the Boolean operators, and that will look like this. Now that makes it a lot easier to read this. Cyclomatic complexity didn't actually change on this. However, from a readability standpoint, we're a lot more clear on what we need to do.
So now you said it didn't change?
No, it didn't.
Earlier I said it changed.
By just taking out the nested ifs?
By combining the two ifs into this and.
Oh shit, I did say it earlier. I'm wrong. False.
I understand that it changes,
Yeah.
but I don't think it is less difficult.
No, so I was wrong when I said it the first time. Good catch. I actually did that. You get a prize. I'll give him a prize.
What is my prize?
Anybody else know why that doesn't change the cyclomatic complexity? I'll talk about it very, very quickly.
The double ampersand.
Because of the logical and. That's still a conditional. That still counts. However, a lot easier to read, a lot better in a lot of other levels. So we got that.
Question on this. So if you're like testing your branches, average, are those those will register the same way?
If you're testing your branches using what tool?
I guess adjust. Like if you're trying to see, have I explored all the possible routes and stuff?
Oh, so you would do that with probably something like,
System.
yeah, I was gonna say NYC is the node command. Istanbul should catch things like that. But in my research for this, I did see that a lot of the code complexity tools and stuff will opt for something that runs reasonably fast and gives you a pretty good answer rather than something that actually teases all those out. Because if you think of that graph that I showed you, like the mathematical way that you would calculate cyclomatic complexity is a formula that you do with the number of nodes and the number of edges. The problem is that like dynamically generating that for like a complex code base might not be a thing that Istanbul can do in a reasonable period of time. So they make some assumptions and do things like regex matching for operators and shit. Good question. All right, number 2, wrapping if blocks and function. If we look at the same thing that we just had, and we've combined the statements, we've flattened out the if. However, we're doing an operation that seems somewhat related. Again, I have no clue what this code does. I think Keith just found it on the internet. If we put this in its own function and call that there, we get 2 big benefits from this. One is now this is a lot more descriptive of what it's doing. If this thing is true, then do this operation. The other advantage is even though we technically have the cyclomatic complexity, now we can test this behavior separately from where we're using it. And that gets us a lot of the way to the benefit of that dynamic dispatch thing. Because each of the functions in that dynamic dispatch, we can test those independently, regardless of the context they're being used in. That's a big win. And then lastly, returning ternaries. So at the beginning, I showed you next to the graph the like write talk and I read the books and stuff. So this is my finish talk function, but I'm basically using the same logic. I've got something in my what I know array, and I'm testing whether that's enough, and I'm returning, well, so what if it was short? And then if that's not true, and I do know enough, then you get my good wisdom. So I can fix this to say, all right, I do this test, and now I return this directly. So there's a lot of advantages to like ternaries in general, but really the biggest win here is just a syntax cleanup. That's a lot less noisy and a lot more clear about what my intent with that operation is. And I wouldn't call this dry per se, but anytime like you're just using the same operator a lot of times, kind of scrapes that shit out. All right, so again, I want you to think to yourself 3 different ways to approach ifs in a slightly more sane way. 10 seconds. I'm not going to ask for volunteers this time. I'm just going to call on somebody.
Factoring the Ternaries. Just basically the same thing. Well, the last example seemed more like an elf than if and an else if, rather than if else. The elf, yeah.
All right.
You should
John.
Talk to our neighbors.
All right, my education partner in crime, Kimberly Schlesinger. She's right. Turn to talk to your neighbors.
So, three strategies.
Basically,
The return generic thing is just
so you find that easy, but instead of because else could be anything, whereas in your case that was an else, right? And that's just for a little.
so. There are only two ways to say it. That's the line.
Right. So that's like I would say that's an easier way for most of those. I would turn anything like I think that's
All right, come back together with me now.
That example wasn't.
All right, Unruh wasn't talking already, so I'm going to call somebody else. You, sir, what are 3 ways that we can make our ifs a little bit saner?
Flatten the ifs,
Flatten the ifs.
wrap it in function,
Wrap in a function.
return and ternaries.
Return ternaries. Have a fun! All right, so very brief review. We talked about cyclomatic complexity, different branches of the code. We talked about 3 ways to avoid ifs in the first place, which was functional chaining, dictionary lookup, dynamic dispatch, thank you. And then we talked about 3 ways to make ifs better, which were flattening, wrap in a function, return a ternary. All right, and that's all I got to say.
Thank you very much, Kyle. We do have some time for questions, so if you have any, please ask away.
What you want to know?
So if you look into the whole Lodash thing with the functions that give you the less and whatever, what's your point or what's your angle on that?
Sure.
Actually completely removing all the conditions and calling them.
Sure. So what you've done with that is by pushing the conditionals into those functions, now you're testing whether or not that function works, but it's still the entire code runs through that. So your cyclomatic complexity is lower, and I always prefer those. Because if it's something like less than, like there's a low chance you're going to get that wrong. But a lot of those seemingly simple Lodash functions behave a lot better than their native counterparts, especially with boundary cases. So anytime that I can, I'll usually opt for, not usually the Lodash FP version, because Lodash FP auto curries and caps, and I just find, and it's data last, I find a lot more pleasant to work with. Yeah.
Can you go through some of the Lodash functions that you're talking about?
Absolutely. So think about like map, filter, reduce. These are like some of our core applicatives. And these are built in, but some other ones that you might get some good mileage out of would be things like reject. Reject is filter backwards. So instead of just saying, hey, I want to filter out anything that isn't this, you can say I want to reject anything that is this. That tends to read a little bit clearer. Things like, you get some built-in shorthands. For example, in the ES5 map, that has to take a function. In Lodash, what you can also say is you can pass it a string. You say, I want to map ID, and that will automatically just give you all of the ID properties on whatever you're passing in. Or like their find function kind of works a similar way, where you can say, I want to find something that matches this object. Like a really common way I'll use that is I want to find ID equals ID or something like that, and it will give you the first match for that. And there's probably 300 or so just tiny ass functions like that that really get you a lot closer to that, like, not necessarily functional, but a lot more declarative style of programming out of the box. And even like your old friends, map, filter, and reduce, get some new tricks. Cool, what else? Yeah!
In one of the code snippets, you had flow.
Mm-hmm.
And what that is, can you talk about that?
That's a Lodash thing. So, hop back. The idea behind flow is the opposite of compose, if you've ever used that. The thing that sucks about compose is that compose will take a bunch of functions, and then, like, anytime you've nested a bunch of function calls and you start getting the pyramid of doom, you can use compose to just make those execute in reverse order. So flow is the opposite of that. And let's see, where is it? Oh, did I go past it? Oh yeah, it was in the function chaining one. All right, so with flow, we take in the array, and what it's going to do is apply each function to that array. So this difference call will go, okay, whatever days of the week currently is, I'm going to apply this function to it. Actually, I didn't. Yep.
First argument or last argument?
Last argument, opposite of normal Lodash, and I actually shouldn't have had this this call in there either. And that's another thing that Lodash FP does, which, like, if you have Lodash FP, you just import from a different namespace. What that'll do is make the data last instead of first, like it is for no good reason in all the Lodash functions. And it'll apply this to it, and then whatever the output of that becomes the thing that gets applied to the end of the next one. So each, also Lodash FP, takes data last, and so that gets applied to this. And that is getting a lot more into like pure functional territory. But like I said, if you've never done any of that kind of shit before, this probably looks a lot more comfortable. Once you've done this even a little bit, like, it's hard to go back. Cool. Other questions? Anything online?
Yeah, question from the stream. Gabby asks if at evaluate multiple conditions, would an and be encouraged with a ternary?
Yeah, I don't have, like, as part of your test, I don't have any problem with that. Where the ternary, like, no longer really becomes probably what you want to do is when the condition gets any more complex than that. Although, consider this. So in this one, the test is just, is this less than this? If it were any more complex than that, I'd probably wrap it in a function. Because then I can say, my test is valid student. And a valid student might need an ID and paid registration and a social security number, and I don't know, whatever else. And then we can say whatever the result of that test is, we can do these things. If it's something simple, less shit to read if you just do it in line. And if it's like this and this, I don't have a problem with that. But in this case, if one of these needed an and with it also, probably wouldn't do that. Yeah, John.
So I have a small quibble with this slide.
Okay.
It's the word return. I would substitute the word use. Because the difference is a ternary is an expression. So if you're computing different things, you use a ternary, it returns.
I see what you're saying.
One. So then you can go use that value however you want. If you use an if statement, you have if, then you have some temporary variable equals, and it's easy. You start doing this mutation stuff, it's easy to get messed up.
Fair enough. So you're not actually returning the ternary, you're returning what the ternary outputs.
Yes, and the ternary can be used to clean things up.
Sure.
Many places that aren't using it in a return.
Oh, absolutely, and I completely agree with that. The thing that I like about using a ternary in a return is that we've covered all of the cases here. There's no other sneaky thing. When you use a ternary somewhere else, like, I would still use that over like an if-else. And that's really all a ternary is just a tighter if-else. But specifically returning it, it gives us a little bit more confidence about that with 2 less lines of code.
What about dropping the else and like having a return early pattern?
So the return early pattern, I don't mind that too much on things like guard clauses, but if we look at that gnarly piece of Java that was in there, you could also conceivably return early out of a lot of this, and I don't think that actually helps the understandability of it at all. Because now it can return here, it can return here, it can return here, it can return here. And then what I had in that example with the ternary thing was 2 different returns there. I just don't like that. I like being able to say, this function exits in one place. I think that's less psychological load. You and your team may disagree. Other questions?
Another question online was general advice. This is from M. Riddock. General advice of working with asynchronous programming in JavaScript.
Sure. So I'm actually not, and this is like maybe the most controversial thing I'll say all night. I'm actually not like super on the async await bandwagon. Storm the crows. I use it every once in a while, but I generally think that functional chains with async code are a lot better. So if I'm doing like successive transformations, I'll usually prefer to wrap those in functions and then do .then function, .then function, .then function. Now, a key difference there, and this is like where what I'm talking about might be different than what's in your head right now, is I think async await is generally preferable to using lambdas, otherwise known as anonymous functions, in those chains. That doesn't read super good. But if you wrap those in named functions, I think that having all those in the .thens is usually a little bit better. And if Dan Levy, who was supposed to be here tonight, thanks Dan, he wrote a library called Functional Promises. Functional Promises that has some utilities around making that a lot easier. And another advantage to doing that like kind of .then style is a promise returns an eventual value. If it's a static value, it will also eventually be the same static value. And so you can wrap things in promises and then just treat all of your code the same way and not give a shit whether or not it's synchronous or not. I wouldn't do that everywhere necessarily. That pattern's called lifting. So instead of like worrying about what's synchronous and what's asynchronous, you just lift everything so it acts asynchronous. So my general thoughts on dealing with asynchronous code, I guess, would be summarized that way. Oh, one more though. On the note of extracting it into named functions, that also lets you test whatever operation you want to do on that separate from the asynchronous part of it, so it's easier to write tests for now also. Cool. John?
Yes, so the examples that like mostly were around, really is around to invitation.
Yeah.
And that every tail has some weird things, who knows what it's doing. That's what caused a lot of crazy if statement stuff. Mm-hmm. A lot of times, conditionals are used around checking the data.
Sure.
To, did I get a bill when I went for some property or something? Where are you on using things like maybes and other monadic and functor type things in those cases?
Sure. So generally in favor of that. The problem is like that's got to be the right team because that adds a shit ton of cognitive overhead to it. Much like the like my functional flow chain, like might look a little bit weird once you've done it. Hard to go back. Dealing with like a monadic structure is a very similar kind of thing. However, those functional chains that I showed serve a lot of the same kinds of things. If you're doing tests, you can do things like reject and then pass the is-nil function into it and get the exact same benefit without necessarily needing to like reach for a conditional. And like taken to its extreme, that's essentially what like a monadic chain is. But like that version with the functional chain is probably going to be more grokkable by more teams. And so even if it's just training wheels or if it's your final like thing that you do, that's probably what I'd reach for first. Cool. Other questions? Going once? Going twice? Thank you so much.